All right, let's get started. Welcome to the PAS Aware Networking Research Group. Oh, yeah, people already running away. See? Yeah, I'm good, thank you. Okay. So I'm Jen. Brian is not with us even virtually. He preferred vacation over all this boring networking stuff. So I'll be alone. This is IETF Note well. Please read it because it basically tells you all legal details which you need to know when you're contributing, when you say something or write something. I suggest you look in the slides, and if you have not done it yet, look at the links. And indeed, as a part of it, when you come here, you agree to work respectfully with people, be nice to them, and if you have any concerns about behavior, we have an ombudsman team which would happy to help you with this. So, housekeeping. I know it's a small group, but still I would appreciate if people joining the microphone queue would scan QR code, use on-site client, and join the queue using light client. It would be much easier from queue management perspective. Remote participants, please keep your audio muted unless you're actively speaking. And for slides, yeah, I can give you control over the slides, so I can be your voice interface to move the slides. Okay, we still need a minutes taker. Please, it's not going to be hard work, I hope. Well, famous last words. Next time, I think we'll make a rule that last person walking into the door when I ask for minutes taker will take the minutes. It would be a nice addition to IETF policy. We can put it in the note well. But volunteers? We even have like transcripts. You can basically type it, what you see. Shouldn't be that hard.
I'm attempting to sign into it, but it's blown me out each time I've tried before.
How many times have you tried?
Apparently not enough.
Yeah, the thing is, we theoretically couldn't proceed until we get a minutes taker. Yes, Jeff, please come in. We are looking for minutes taker. Now you see, I'm scaring people away. We have 5 minutes to spare, yes, on the agenda. So I'll be, because unfortunately I cannot take minutes because I don't have enough personalities. Thank you very much. I will cover minutes for your talk. Thank you. This is your hero. We need badges. Oh, superstar. Yeah, obviously. I know we have these digital badges both, so I think we need to introduce digital badges for minutes takers, heroes. Thank you very much. Okay, agenda. So I'm going to take a few minutes of your time, and then we're going to have some updates on Cyan and discuss open research question on Cyan, deployment issues, exciting, practical stuff. And then we're going to have 2 lightning talks about PANRG traffic ratio and academic work on pass verification protocol. Any last minute agenda bashing? I don't know, anyone came up with a great lightning talk we shall hear today? No. Okay. In this case, it's all for the chair slide because we have not published anything. Really, there is no documents update. So let's proceed with the first presentation about draft updates. Okay, you asked to share the slides. Wait, why I am not. What? What? I'm not
All
getting.
right. I asked from the tool.
Yeah, hold on. And your request disappeared from my. Can you try again?
Let me try again.
Try.
Did you
Ah,
get it?
yeah, okay. Grant preload. Yes.
I have to select
Yes, I think you need to select
confirm.
what you're going to share.
Yeah.
Oh, yeah, I can see it. Great. So the floor is yours.
All right. So thanks a lot, Jen. And well, yeah, if the research group wants some more drafts, actually, we have some ideas later today. So uh, yeah, happy to share that. So my name is Nico. I work for the Scion Association, and I want to give a brief update of what happened on our internet draft. So I think the last time that this was a topic with the research group, it was back at IETF 118 in Prague. I assume that if you are here, you probably already know what Scion is about, and if not, there are a bunch of drafts. There is an overview draft that you can read. Um, this is a path-aware architecture. We have some early adopters in the field of finance in Switzerland and so on. And we have three core specification drafts that are the ones that you see down in the slides. And yeah, I want to share some updates regarding these three drafts today. So back then at last meeting, we had a couple of presentations by some of the early adopters. So we had six, and they presented some things about the banking network that is based on Scion. We had an Apaya, the Scion vendor. They also presented some operational aspects of Scion back then. And then we had our usual discussion: where does this work fit? Is it something for the research group? Is it something for somewhere else? And after some rounds of discussions, we ended up submitting the core specification draft to the ICE. So this now has been under ICE reviews for a few months. And so I will share a bit some of the updates that we have done to the draft. Our goal with this draft is to document the existing Scion deployment as it is deployed today. So that also means that on this part, we don't want to do uh, that many changes yet. We just want to document what is in production. But of course, we also want to start thinking about potential evolution for the protocol. And that's why today in the later presentation, we will introduce two new drafts to start brainstorming about that. So regarding Scion draft, here you can find a recap of what we have. The core specification consists of three main component drafts. We have a PKI, we have a control plane doing all the path discovery stuff, and then we have a data plane doing the forwarding. And these three are the drafts that are under ICE review. There is an overview and a component draft that we wrote some time ago. I think these today are not really maintained, so I think one of them might be expired. And later today, we want to introduce some ideas for some drafts that could potentially fit in this research group regarding some of the open research questions that we have and some of the deployment experiences. Uh, Regarding some of the updates, one of it is about IPR. So on a PIA system, the Scion vendor has submitted 3 IPR disclosures regarding their intellectual property on Scion. So I think the licensing terms on 2 of them are quite liberal, no license required. They are patents that mostly concern not directly the core protocol specification, but more like optimizations that they have in their own stack. So if you want to know more about it, I think here you can find the link to the IP disclosures. We have been looking at it, and we're also not aware of any other IP in relation to Scion. All right, so going back to the draft, there was actually quite some work that we put in onto the draft. So part of it focused on making the drafts a bit more self-contained in view of the I submission. So we have a new introduction. We have also some new sections with some clarification. We have been doing also a bunch of editorial stuff, for example, regarding wording and so on. A big part is on security considerations. It is something that was missing when we presented these drafts here in the research group before. Super important, so now all drafts have it. IANA actions, well, there are no IANA actions, but we have a reference to the current registry of SCION numbers, so these ISD and AS numbers. This is currently maintained by Anapaya and in the process of being transitioned from them to us, a SCION association. Besides that, let me give you a quick overview of the content that we added to the drafts. I won't have time to go into the details, but I'll try to leave quite some time for questions so that if anyone has questions on a specific topic, we can look at it. So back then, in one of the past meetings, there were some questions regarding time and SCION. SCION is doing this path discovery with segments that expire and their certificates and so on. So time synchronization is actually a loose requirement. So we try to make this clear by outlining in the draft what are the dependencies, what is the clock skew that can be tolerated between components. It is within the order of minutes. We also added a section about what is required to configure to run SCION AS in terms of, for example, link interfaces and so on. So we hope that this is making things a bit clearer. Then we added a few more content to the various components. So on the control plane, we tried to clarify some of the validation requirements for segments, also in relation to time. We also added a bit more details regarding some of the APIs that connect the various components of the SCION control plane. So part of it was not really fully specified, and we added some text. There was actually some work on this at the hackathon at 118. So the API originally was using gRPC on top of QUIC on top of HTTP2. And there was this hackathon project of pumping this to HTTP3. Actually, it seems like this is now making into the actual implementation. So we updated this into the drafts as well. One new section is as well about scalability. So this is a topic that we introduced quite a lot in our presentations. The key concept is that the SCION routing plane is split in two parts, a core doing like inter-ISD routing, and then an intra-ISD routing. And while this helps overall with scalability, there are still some trade-offs to be explored, especially when you look at the core beaconing part. This is based on some kind of flooding. That means that if the core SCION network grows, then this would scale poorly with this approach. So the way that the implementation is handling this is with limiting the amounts of, let's say, routing discovery signals, or what we call path construction beacons, to a certain number. So we added a few considerations on that, on the trade-offs in terms of overhead versus discovering a certain amount of paths. I won't be able to go more in the details. We also added some text regarding the time that it takes for the architecture to discover paths, also in relation to a feature called path recovery that allows for paths to be discovered, let's say, quickly in case of network bootstrapping. We got some questions. This comes a bit from the ICE review regarding the data plane. So the data plane in SCION uses this message authentication code, and this is what we call MAC, so this is not a MAC address. We added some clarifications on this mechanism and on how this works. On the recommendation of our reviewers, we also introduced a compulsory MAC algorithm, AES-CMAC, which is today supported by both main implementations. We made it mandatory in the draft so that this can support interoperability between vendors. Coming to the security considerations, I think this is a very important piece that we added actually already before past IETF. So what we try to do in the draft is to clarify what are the security guarantees that are provided by by the current implementation, especially by the current implementation of what we call vanilla Cyan, what you have in this draft. So the main objective, security-wise, is to provide path authorization, or making sure that the paths that are made available to endpoints are actually authorized by the operator. Of course, hijacking prevention is also one of the security properties in mind, so we discussed that. There are, of course, a lot of other experimental extensions that are not part of this ICE draft that can do a bit more, but as they are not deployed in the production network, we thought we would leave them out. So going a bit more into this direction, we added some considerations around the control plane and routing, adding some potential attacks to routing. Specifically, there are some cases where a malicious, actually a pair of malicious autonomous systems that you can see here, and actually each node in here is an autonomous system, could collude, for example, to advertise a large number of links between each other with the goal of attracting more traffic. Or there is an attack called Wormhole, where two distant autonomous systems, they create a tunnel between each other. So this is the case you see on the right. And they use this tunnel to fictiously show that they are closer to each other to try to attract traffic. So we discussed a bit the implications of these attacks, how this can be detected. Avoiding them is intrinsically quite difficult, but there are mechanisms for potentially for detection. On the PKI, if you remember how Cyan works, basically path segments are authenticated. That means that you have a dependency on the PKI, so you need to be able to get the certificates. So we added a bunch of considerations on that, also on how these certificates can help prevent that an AS is spoofed. On the other hand, we also had considerations about the availability of certificate authorities, as these certificates are quite often short-lived, so they need to be renewed quite often. We have also some considerations about the data plane regarding path hijacking. So when it comes to path discovery, the fact that paths are authenticated means that hijacking is difficult for an off-path AS that might try to, let's say, spoof this path construction beacon. In the data plane, there is a case where an on-path attacker might be able to divert traffic into an already authorized path. This is possible because the vanilla Cyan implementation described in this draft does not provide full integrity protection in the packet. This can be avoided by adding a mechanism that provides that. So there is an experimental extension similar to IPsec that can protect it. The attack model here is already relatively strong because the attacker is already an AS on path. Besides that, regarding the data plane, we quite often got questions regarding this MAC mechanisms, the length of the MAC message authentication code. So this is 6 bytes. Is it sufficient? Is it not sufficient? So we have a discussion on this, on potential collisions. Another aspect regarding the Cyan data plane is that at forwarding, all routers in an autonomous system share the same key. And so that means that in case of compromise, of course, path authorization is temporarily compromised within the autonomous system. So we add some thoughts regarding that. There is a discussion about path splicing. So that basically consists of stitching together various path segments that were not originally meant by the original sender into something that is still authorized, and this is generally prevented by a field, but of course there are some trade-offs in terms of field length. So we have a random segment identifier, and we discussed this as well in the draft. Last topic is the denial of service attacks. So a path-aware architecture can help when it comes to volumetric DOS, especially when it comes to reflection attacks. Paths are usually reversible, so that means that it becomes a bit harder to do reflection attacks as traffic would come back to to the source. When it comes to volumetric DOS, if a link gets congested somewhere on the network, path awareness can help basically get around this. But on the other hand, there is not too much that this can do for other layer attacks, so like application layers attacks. So we try to clarify that. We also add a couple of considerations regarding DOS attacks and the control plane, because of course, for being able to communicate, you need to do these path lookups, and that means that the control services are available. So we introduce some of the strategies that are used today in terms of filtering. And I think with that is all regarding the draft updates. Then another really interesting development was Nether. So we had the BOF this morning, and we see how some of the use cases are very similar to the ones that are use cases of Scion. There is a bit of difference in the sense that Scion today focuses exclusively on interdomain and not really on intradomain. So in that sense, depending on where the BOF is going, the two things could be potentially complementary. There is a strong component of path awareness in Nazar, where paths are already discovered in an authenticated fashion. And so one other difference is that Scion in the specification that I presented today does not really do proof of transit. This can be an additional auditing tool. I think we discussed this in the BOF as well for some use cases, but we believe that if you already have a strong, let's say, path discovery mechanism, then the benefit of adding proof of transit on top of it are a bit more marginal. This is also why we don't have it in the basic implementation. There is, of course, an extension coming from our colleagues at ETH, and they have also been exploring proof of transit in Scion as well. I believe Antoine that will also cover this part. And yeah, with that, I think that's it regarding draft updates. So if you have comments or questions, I think we can open the floor.
Yes, I do not see anyone in the queue. That's
Today we're a tiny group.
yeah, it's a tiny group. It's low attendance today. Yeah. Guess everyone tired. So what's the next step?
In terms of next steps, we are now going through the ICE review process for the specification, which is pretty much the best place that we could find right now to just take a snapshot of what we have today. I think based on the feedback that we received there, and depending on the interest of the research group, I think next step would be to see if we can start thinking about potential evolutions of this. And I think on that, our presentations that we have afterwards are going a bit in that direction. So there is a big research community that is still doing things around science. So I think Juan will be presenting something very shortly. And we have some deployment experience that I think can be helpful. So can we bring this into the research group? Yeah, that's a bit what comes next. Besides, of course, trying to get the specification drafts in a good shape so that they can be published.
Yeah, and I guess it's still time for the group to read your specification and come back with
I
some
would love
feedback,
to
right?
receive more feedback. I think
Yes, so please.
over time, we did get a few hints. So for example, this topic of time synchronization, I think this came out of, I don't remember if it was 118 or 117. But yeah, we would love to get some more feedback, and we will be doing a lot of polishing work on these drafts. And we like to receive difficult questions.
Okay, yes. So again, I would like to ask people to read the draft, send the feedback, and as there are no questions, I guess we can move to the next presentation, which I believe going to be remote. Yes, Juan, Are you going to move the slide yourself, or you'd like me to?
I can do it myself if that's okay with you,
Okay.
Jen. All right, so let me share the screen.
Yes. You share. I, uh, yes.
You see it?
I just granted you permissions.
Mhm.
What? I did click that.
All the slots for the requested media are already taken. If not, if that's okay with
Yeah,
you,
if
you can
not,
also.
I think you should. Are you still?
I will stop. Okay.
Okay, now.
Okay.
Yeah, remember it's between.
Now, yeah.
Okay, let me
All
see.
right. So let me just do the whole screen.
Yes, yes, thank you very much. Okay, yeah, let me start the timer.
Mhm.
We have 15. What? No. Yes, 15. Yeah, I think we're good. Thank
Okay, so thank you very much for letting me present this draft that we created some days ago about some open research questions that we still have regarding Scion. And we believe that PANRG is the perfect venue for this topic since we see Scion as one instantiation of a path-aware network. Thus, many of these problems are just common to many of the different types of architectures for path-aware networks. So I'm gonna be talking about the draft that we created a bit, and then I'm gonna run two examples of these questions that we have just for the audience to kind of feel what we're talking about in general. If you're not familiar with Scion, I've prepared 3 minutes to clarify the core beaconing process or routing mechanism to find paths in the core network in Scion through these path construction beacons that Nicola was talking about before. So just going ahead, why do we want to have this new draft talking about research questions in Scion? We have Scion running in quite some ISPs and so on. Well, we've done this since the beginning many years ago. First as an academic exercise, and then later talking to some ISPs, figuring out whether that was realistic or not, and so on and so forth. But I think it's now the moment to start talking about internet scale adaptability and whether we are prepared for that or not. So this set of questions that we wrote in the draft are some questions that we believe we must answer before being able to tackle internet size networks. At the same time, we need to ensure, or we need to know that software developers, the ISPs, and the hardware vendors are okay with all our assumptions that we have tried to verify, but we are never sure until we really hear from them that this is okay. And at the very end, all this is in the hopes that some years in the future we'll be able to standardize Zion, be it Zion with this name or with some other name as a path-aware network, so that it could be deployed widely. Okay, so these are the four classifications of these research questions. We've piggybacked on the open questions RFC about path-aware networks. There is an RFC for that, also presented some years ago in here in this group. We see here these four categories. We have the discovery, distribution, and trustworthiness of path properties. That's one of the categories of this RFC that the RFC proposes. Then we have also this data plane stability, where we have two points over there, and the rest of the topics are more in regard to software development using these tools. I will give two examples of problems in the control plane because I think that's core to the architecture and also exemplifies quite well what type of questions we have opened at the moment. If anybody has any particular interest, we can discuss that. Any topic that we had in the list. So just a refresher, how is Zion finding paths or doing the routing and so on. We have here some networks, some autonomous systems with some interfaces, some egress and egress interfaces. What they do is they create these PCBs or path construction beacons, these tokens, where they write down in a cryptographically secure manner their AES numbers and the ingress egress interface numbers for them. And then basically they have the choice either of creating new ones or forward new ones and so on and so forth. So it's similar to a flooding algorithm in essence. It's just some qualifications that we're going to do on top of that. But in essence, that's what's happening. Yeah, we see that beacon traversing now, it's going to go to AES4, maybe to AES5 later, and so on and so forth. So as you can imagine, this with many number of interfaces, this could create a geometrically growing number of PCBs that would be arriving to this network. So what the AESs do essentially is they select which PCBs, which tokens, which they had received look better than the other ones. They rank them essentially. So they rank them and they forward the ones that are best first, and then as time goes by, they will be forwarding the other ones as well. Now we have to remember that each one of the AESs have private policies that they want to preserve. They don't want to forward traffic from one interface to certain other interfaces and so on. So that policy definitely comes into play into this filtering, into this ranking function. Also, even though that in general the flooding algorithm will be exponential, the number of PCBs will be exponential, since we have these filter functions or these ranking functions, they grow constantly according to the policies of these AESs. And usually these ranking functions take into account the connectivity. So for instance, have I seen that AES first or not? So trying to connect as many AESs as possible, of course. But there is also metadata in those beacons that might be very important for other networks to select them or to be able to select those paths. For instance, according to latency. Yeah, the metadata is I didn't draw that on the diagram, but just imagine that these beacons also get annotations about latency, bandwidth, available bandwidth, or max bandwidth, and so on. So at the very end, what we have is just that the AESs that receive these beacons have received a filter version of what the complete network looks like, but that filter, that ranking, is a composition of these ranking functions of each one of the AESs that were on the leading part of that path. What we want to solve at internet scale is how can each one of these AESs that we saw in that picture communicate the preferences, what they would be good for them, or their ranking function, essentially, or the semantics of that ranking function, to the AESs that would be forwarding those beacons. While at the same time, we would love to preserve the privacy of each one of the AESs that's given to the transit AESs, and at the same time, if possible, to be anonymous, so that they, some kind of trusted computation, but ideally in an anonymous manner. Okay, that was maybe a bit abstract, but we can go back if during the question time somebody has any comments on that. The same idea would be inside the AES, so an intra-AES communication to the endpoints. How do the endpoints tell the local AES, the local network, what type of path they are interested in? So it's different for different applications. A video conferencing tool probably wants to have a very low latency path, while FTP application would love to have high bandwidth with not too much regards about latency, if they were completely orthogonal. Yeah. So yeah, there's the same principle. Also, possibly a solution for one would be a solution for the other, but we don't know yet. Now, a simpler topic that would affect kind of a lot of architectures, path-aware network architectures, would be if we have a path that is being used from a client to a server. And that communication going back from the server to the client, so the reverse path, is going to last for quite a lot of time. What happens if that path is about to expire? Yeah, that's a question that we had among many of them. Um, whether we even have to standardize the way to do that, whether we have to introduce a way to specify policies from the client to the server to pick up the next path, whether per convention they will always use the same interface sequence and just renew when possible, whether the client needs to send again a request, even an empty request, just to refresh the path, and so on. This is a very simple question, but we also ask ourselves, yeah, should we actually standardize something like this, for example? And questions like this, we have a lot. We have complex questions like the one that I presented in the control plane, and simple questions like these ones that we have in front of us. So I think it's quite interesting for the path-aware network community if we can think about these problems and find a general solution. And in the scope of SIDE, of course, we can implement those solutions directly in the network. Thank you very much. Thank you, Jen. I think if anybody has any questions, please, we are definitely looking forward to have feedback also in the mailing list to the draft anywhere. So we really want to have collaboration with PANRG in the community.
Great, thank you. So we have people in the queue and we have even more time than expected. So we have about, what, like 8 minutes for questions. So please, Antoine.
So, hello, Antoine Strancourt from Huawei. I'm wondering whether you are interested in listing potential solutions in the draft, or you are just interested in listing the questions, because, for instance, with regards to how you share policy between the EASs, there are some works on using secure multipass computation or all those kind of things. Are you interested in listing those work?
Yeah, definitely. So in this draft, we had to, I had to say that we had to put this almost in a rush. So we only took like 1 week and a half to do it. So it's definitely incomplete. We don't have all the questions, and definitely we don't have all the solutions that we had proposed in the book or in the recent research and so on. But the idea for us with this draft is to start asking the questions that we need to solve for a protocol like SIAM to be suitable for the internet. And once we have one of those questions, for instance, like we were saying about the control plane, how do we select the beacons? Propose solutions, definitely, and then have the critiques and find out which one of those solutions would work better or would be more favorable for certain types of networks that we are interested into. Like trusted computation, for instance, is one of the approaches that we have for this beacon selection. There we had some works as well, but right now in this draft we didn't include the references to them. But it is more than welcome to, if we receive feedback either in the draft or in the mailing list, that would be awesome, definitely.
Okay, Hashem, you are next in the queue.
Yeah, I have two questions. The first one is, have you thought about using machine learning and large language models in science?
Um, so we had a talk some years ago about modeling networks and applications, and that would refer in the slide, in the points that we have here, that would refer to point number 5. How do we interface between the application and the network? And though we have certain ideas like TAPS, the TAPS working group, we also thought about using a textual description or a human language description about what a network looks like and then what the application is doing, and then trying to get out of that the important tokens or the important vectors, let's say, in that language, and then map that to properties that we know about in the real network, like latency, number of hops, geographic positions, and so on. But aside from that, we have not worked in that direction.
Okay. My second question is, uh, which part of Scion is ready to be standardized in IETF?
To be standardized for public use in the public internet, I'd say, of course, we could write a draft about, for instance, the PKI, why not, or certain components that we have. But I think what we want to do is try to fix the problems that we foresee will appear if we try to deploy this architecture to all the networks, every autonomous system in the world. Even also because we have fundamental questions such as how many ISDs, how many trust domains are we going to have in the global internet? And what does it really mean to create an ISD, to create an isolation domain, a trust domain? So for that, that's why we are now starting to ask these questions to the community to find out what the consensus is, what we think it will be later, and then we can start writing, for instance, the PKI draft. Just refining the one that we have in the eyes, so that with the intention to standardize it, not only to report what we have, but also to standardize it.
Okay, thank you.
Thank you.
Okay, so I see no more questions. So thank you very much, Juan. I guess you can
Thank you, Jen.
stop presenting. And then Nikolai, you are next. Again. Okay, I'm getting better at this.
Me too. All right. Yeah, so that's the last Scion presentation for today. So following up on what Juan mentioned on research, there is also some experience that was gained in these early deployments. I mentioned this before. We have some productive deployments in the field of banking. And if you remember, this working group, this research group has worked on RFC 9217 in the past, laying out some of the open questions in path-aware networking. And we thought that maybe our early adopter experiences could help to maybe answer or learn some lessons out of these early deployments. And in this RFC, there are questions such as, how can a path-aware network be practically operated? What are the incentives for operators? And I think we might have sometimes some answers, sometimes half answers. I think it would be very interesting to document this and discuss, keep the discussion going on with the research group. So we laid out a draft. This draft as well is really just a skeleton right now with some open points of ideas that I think could go in this direction. So one of it relates to, for example, deployment models and interoperability. This was a topic, I think it was also raised today at the Nazarbayev, that Scion today in the productive network is still using a gateway for the finance network that do translation from Scion to IP. Is this viable on a global scale? Do we have to look at other approaches? So there are more research implementations that push Scion down to the stack, but of course this is a lot harder to deploy. So I think here there is some interesting lessons learned. Besides that, we also have, with our community of early adopters, we also have some material, for example, some operational guides regarding, for example, running a Scion network, running its governance. There is a whole PKI that introduces some, let's say, special governance models for these ISDs. And for example, in the banking network, they came up with some policies and processes and so on. So I think there is some material. These people are not necessarily people that show up here at IETF meetings, but we thought it might be interesting to bring some of these topics here. Another topic is regarding scoping of these ISDs. I think this was raised by Juan. So right now we have these semi-closed networks in finance. Then how do we take this to a wider scale, or is this just the let's say niche where Cyan belongs as a solution. It could be. I don't really have an answer. And I would love to hear, I think, people's thoughts on this. There are some additional operational questions and also experience learned, for example, in running these autonomous systems. There is all the aspect of managing the cryptography, certificates, rotating them, and so on, setting up these control services. This is something that we don't really have in the ICE drafts, as they mostly cover the specification, and it is something that I think might be interesting perhaps for a research group. There is the topic of connecting ISDs. So this goes back into this topic of whether you have like some semi-isolated networks or something globally connected. And here we have a bit of both. So the banking network is a bit more isolated, but there is a research network that is a lot more interconnected and global. So that is another topic. With that, I just wanted to lay out some ideas. We have just a skeleton of a draft, and if there is interest to go into some areas, we would be happy to put the effort and bring some of these topics into the draft. Next IETF will also be in Europe, which makes it also easier for us to pull some of the people from the science community and fly them to the meeting. So maybe there is something that is not so interesting or something that I completely overlooked. My question for the research group is this topic interesting? Which areas should be covered? Which areas should not be covered? Yeah, and maybe based on that, we can also see if we can get the right people to the next IETF.
Hi, Colin Perkins. My phone is not working to do the connect thing, so I'm just going to come to the mic. So, I mean, there's clearly some interesting problems here. Is your goal to just document the issues and possible solutions, or is the goal to use this research group and the broader IETF community to help build connections and maybe do some deployment experiments and help with larger scale deployment experiments, for example?
Thank you. I think when it comes to the research draft that we presented before, that's where we would like to collect some of the open questions. I think this very much relates to deployment. In this case, a lot of time talking to people a bit in the ICE feedback, based on the ICE feedback, we got the question, but how does it look like to operate this? And there is a lot of interest around the finance network because I think it is a bit of a unique case. So the goal for me would be to share, I think, some of the experiences with the research group. Maybe if there is enough appetite from the research group, this could also be work that could be perhaps adopted if there is enough interest, with the goal of basically documenting the experiences. And this is because really we talked a lot to some of these early adopters. They are not showing up here, but I have a pile of documents that document these operational practices and topics that I had to discuss. And I think it would be great to bring them into a research group.
Yeah, sure. I think it would also be useful to try and get some. I think it would also be useful to try to get some of the early adopters to come to these meetings and try and build a broader community of adoption and do some more experimental deployment type experiments, perhaps linked to the hackathon and so on. Especially if the goal is, if the long-term goal is to move this into the IETF, starting to build a community of deployment practice that is linked to the IETF community, I think would be a valuable thing to try and do. And I'm not quite sure how to do that, but I think that would be a valuable thing to do.
No, absolutely. So the challenge is that being most of us based in Europe, it is a bit hard, but I think last year we met in Prague. I think this year we will be in Dublin with a few more people. The hackathon last year was a very good, had a very good outcome. I mean, it was still among Scion people, but we got this this update to the control plane APIs that actually now is making it into production. So I think I found it very cool.
Yeah, no,
but
it's
yeah.
it's absolutely very cool, and I think if,
So
even if you're just able to come once a year and get people to hackathon at the European meetings, that starts to build visibility and starts to help you build connections with the broader set of operators and the set of people in the IETF. So
yeah.
I would encourage you to do that sort of work.
Yeah, absolutely. And I think the other open topic is a bit Nasser. So I think I mentioned that earlier. I think that the problem space overlaps. So also depending on how that goes, I mean, this could be a potential venue to then take some pieces of Scion or lessons learned in there. But I mean, this is still I think, early stage to tell whether we fit or not.
Absolutely. Thank you.
Yeah. First of all, I'd like to proxy a comment from Mohammed from the chat room. He's saying that deployment aspects mentioned are very interesting, including logistic matters such as bootstrapping, TRC or ACD, and so on. It would be useful to consider the same document can conclude also how Scion answered questions from RFC 9217. Yeah, and yeah, so there is Juan also saying that we might need to see more of a map between RFC 9217 and Science Solutions. Now with no hats on, right? As a operationally focused person, right, I really like to see deployment experience documented and prove that the experiment is going out of the imaginary phase to actual practical phase. Yeah, so I think it would be a really good idea to show what you've done, what you discovered, what was unexpected.
Regarding the topics that we outlined, is this something that makes sense, or is there something that
I think it might. But the thing is, because I don't have operational experience with that, it's really interesting for me to see your input because I don't know like how to do that. Yeah. So I think if you want to see more people doing this, you need to provide recommendations how to do this, right? Where to start and what to expect. So I think it's a great idea, and I hope that next IETF in Dublin, right? Dublin, yes. So I guess we can. European IETF. I know that Brian will be here. So while he is not here, I'm volunteering him to help. So we definitely.
Thank you, Brian.
Yeah, you see, we definitely should continue working on this, right?
Yeah,
because, by the way, question. So have you considered going down to operational communities like RIPE, which will be just before IETF?
They will be in Prague. In Rome, so.
So like Prague will be just a week before IETF, like next RIPE. So I don't. Because I guess operationally minded people, would like to hear more about.
So I
practical.
think my co-author Kevin Meno, he's now with us.
Yes.
So
okay.
He will be at RIPE as well. So we are trying to connect better with this community as well.
Nice. Any more questions? No. Okay, thank you very much. So looking forward hearing more from you. And the next presentation is Luis. Nicola, I guess you need to stop sharing. Yes, you monopolist. I can probably click here. Oh, I have all the power. Yeah. Okay. Would you like to share, or do you want me to?
If you can share.
Yeah, absolutely. I'm just.
Thank you.
Okay. Hold on. Confirm my selection.
Okay.
Yeah.
So, hello everyone. This is Luis from Telefonica. I will present an update on the draft describing the PANRG traffic ratio API on behalf of my co-authors that you can see listed in the slide. So next, please. So the motivation for this was the working in the direction of providing visibility or observability about the energy consumption related to a path, to a given path. Thinking on services like SD-WAN services or other services like in the future slices and so that could make use of a specific path. So somehow, defining means of collecting the information related to energy consumption for that particular paths. This means to have metrics about the power consumption between a source and a destination. So and as we all know, there could be different alternatives for that. So the idea would be at the end to decide what could be the more convenient path according to the request from the customer. So the objective is to define such a kind of API. We started defining a REST API. Now in this new version, we have also provided some idea of YAML module about that. And as said, this information could be consumed either by external applications like SD-WAN or any other kind of service, or even internally. So for the internal decisions of the operator in overlay services that could be CDN or could be packet core or this kind of overlays that could run on top of the transport network. We already presented the draft in Prague, if I don't remember wrongly. So yeah, I will comment on the updates right now. So next, please. Yeah, the rationale for this is there a lot of discussion. There is a lot of discussion about the how we can, let's say, allocate a given energy consumption for a specific customer. Certainly, the fact is that the consumption of the equipment right now with the capabilities of the devices does not change too much with traffic. So we are far from having this proportionality. So there are different analyses and studies. You can see some reference here. We can say that maybe the consumption could be something like a Pareto distribution. So 80% of the consumption is constant, independently of the traffic that is being carried, and the 20% or even less is proportional to the traffic. That is the case nowadays, but we can expect that in the future, with new capabilities on the devices, we could have more proportionality of the consumption according to the traffic being carried by the devices. So it is with this expectation what we are somehow researching on the possibility of having this kind of API. Next, please. So as said, the objective here would be to have ways of exposing the consumption for a given path. So what we can expect is that some kind of system requesting the network controller or any similar component a view of what is the energy associated to a service. The energy consumption will be dependent on the path for sure, and the path at the end is dependent on the device characteristics, the architecture, so how many layers, what is the topology, the transceiver bit rate, so what is the speed of the transceiver, number of hops, also dependent on what is the energy mix feeding the point of presence where the device is hosted, and so on and so forth. In the example of the REST API that we presented in Prague, we were focusing on basically in the watts per gigabit, so the energy consumption itself, the energy ratio. But we are now providing some ideas of some other information that could be of interest. Next, please. So in this respect, in addition to the watts per gigabit, we are proposing now carbon intensity and renewable percentage. I mean, the usage of renewable energy. By carbon intensity, we refer precisely to the fact that for a same level of energy consumption, depending on the energy mix of is feeding the point of presence, we can somehow deduce some kind of a carbon footprint for a given device. So this is why we are considering that. And the usage of renewable energy would be basically to retrieve or understand what could be the proportion of this energy mix that is feeding the devices that are somehow being used in the path. So we have added these new attributes. We also have worked on a subsection for recursive usage of the API, so we could have multiple layers, so we can somehow request the retrieval of the information for the IP layer and then for the optical layer and so on and so forth, so doing subsequent requests. We also have added an initial description of a YAML module, so that we will somehow work on the direction of the API, but also having a YAML module that could be consumed by other systems. The recursive usage would be one of them, for instance. Also, we have reported some potential IANA considerations for the attributes and so on. And finally, we added Jan Lindblad as well as co-author of the draft. Next, please. So by next steps, we expect to collect feedback from the research group to check interest. I think that there was some initial interest in Prague, but so this is to recheck if there is interest on continuing this as part of the path awareness stuff. Also, we would like to understand what would be the best home, let's say, for this work, if PANRG, if Green, other. By now, we are considering to keep it in PANRG because it's related to the path, so makes sense. And maybe could be the case that could be also, could be placed, let's say, in other home. We expect to report on implementation status. We are implementing this API in Telefonica Lab with the colleagues from Cisco that are participating in the draft. So we have an initial implementation, but we need to refine the implementation. So the API is there, but it's not yet totally clear, let's say, is the kind of metric that we can report. So how to obtain the value, how to process the value. So hopefully for the next time that we will present this, we will have more clear view, and even we can share also the implementation of the API and so. And the target is to have a new version for IETF 1.2.1, and let's see if at that time we can report the implementation and so. So that's all from my side. Thank you.
Great. So I see people in the queue. Michael.
Hello, Michael Welz, University of Oslo. Apologies if these are stupid questions because I haven't seen the version 0 and 1. I'm just curious. I mean, I understand this is just an API, but is this API, is there any description of how you would obtain the information that the API is going to provide?
Well, we don't provide the details in the draft. What we are essentially doing is collecting the information from the devices using OpenConfig, and without calculating making proportional to the traffic that we are injecting, we are calculating what could be a potential allocation of the energy for the customer. So these details are not in the draft, but this is somehow the mechanism. So we have the path traversing some routers, sorry. So we have clear what is the path. With that, we are collecting the information of the energy from the SFPs, okay? And with that, we are building something proportional to the traffic. For sure, the metrics should be refined more. We acknowledge that it's not very good metric, but more or less this is the idea of implementation.
Yeah, traffic proportionality was the next thing I wanted to ask about. So okay, so are you assuming a linear function, which maybe is the most common?
But by now, yes, as said, we are just considering the energy of the SFP. So we are ignoring the energy of the fan, the chassis, all of this. So we are doing proportional right now.
Okay, thank you.
Welcome.
Okay, so Genshin from Huawei, and my question is that for this new added parameter named a carbon intensity, so it's mainly for runtime or it's for the full life cycle?
Well, it's a very good question because somehow the carbon intensity has a notion of long run. Is probably having a very real-time value make no sense because it's so variable. So it would be more a perception of long run. So to have a kind of average, what would be the energy mix that is feeding the particular point of presence that is hosting the device. So that would be probably what makes sense.
Okay.
Because in real time, you probably this would imply complications of having interaction with the mechanisms that are somehow controlling the electricity grid and so this is quite complex. So probably would be essentially looking at what is the average consumption along the time, maybe per month, per week, something like that, and then applying that value.
Thanks a lot. I think this is super interesting. How do you envision this information being consumed? So is this something that you do for reporting, or is this something that you envision being actively leveraged for routing and for making perhaps routing decisions?
By now will be basically reporting. So somehow trying to support also the sustainability goals of the customers if we are thinking on external customers like the SD-WAN and so. For the internal applications, probably could be just, again, reporting. For routing, probably similar metrics could be used, but this would not be the mechanism for being used. This is basically for exposing.
Okay, thank you.
Okay. Michael, are you in the queue? Yeah.
Is it my turn again? All right. Michael West, University of Oslo. Not a question, but a suggestion. I think it could be interesting to also add certificates or labels to this. You know, there are routers that are certified to be, I don't know, have a certain level of greenness in the way they're being constructed. So with that, you could be possibly getting the information that on this path, all the routers, you know, have been built in accordance with some green standards or whatever. I mean, it's just an idea because it would be pretty static, right? Not so hard to provide.
It's an interesting idea. We will think on that for sure. There is some effort in the benchmarking working group for benchmarking the consumption of the routers. Probably that could be the source of that kind of labels that you are mentioning.
I don't mean consumption. I mean in production. You know, like when you buy a device, that device may carry a label like it has been produced.
Okay.
CO2 neutral or whatever.
I see.
Right. So that sort of thing, and that's a very static, simple information to include and maybe useful.
I got it. Yes, this could be kind of property of the router. Yeah, maybe it could be part of the inventory information even. It's good idea. We will think on that.
Just a suggestion.
Thank you for the suggestion.
Yeah, I want to put myself in the queue with question. I'm trying to, okay. So I remember reading the draft. Please correct me if I'm wrong. So you basically, I think the draft is saying that here is API, but how those values are calculated are out of scope, right?
Yeah.
So just again, a stupid question. So do we know that those values can be calculated?
Well,
It's like, is it fundamentally possible to know like renewable percentage and carbon intensity to be reported by a router or a path?
Yeah, in that case would not be reported by the router. That
The
would be
path.
taken from an external system, maybe inventory or so, because depends on what is the energy mix of the point of presence. So that would not come from the router. What we could come from the router is basically the consumption of the active parts of the router. So as the ports, the transceivers, the card, that would be obtained. That could be in principle obtained dynamically. Also, it's true that could be obtained from the inventory, but other things like the energy mix or whatever that green property and so would not be retrieved from the router. Probably we require to retrieve from the inventory or something like that. So from some static source of information.
I'm just curious if it's like static, how does it relate it to path?
Well, for instance, the energy mix of the green label would be a property of the router. So depending on the path that we take and the router that we pass through, we can retrieve that information. So even being static is a property, let's say, of the active element that will constitute the path.
Mm-hmm.
So we need to associate that.
Okay, I think I suggest you look in the chat because Juan sent some link to some research paper
Wonderful.
about carbon intensity routing. Yeah, so please take a look at the chat after your presentation.
Thank you so much.
Thank you very much. No
Thank
more
you.
questions. Okay, so Antoine, you are the next presenter. Yes, hold on. I granted you. No, hold on. Hold on. Probably it. No, stop slides. Okay, can you try again? Yes. Okay, and now I. Okay, beautiful. And
Okay, so hello everyone. Today I will present some work that we have been doing in Huawei with my colleague Luigi Iannone, who is in the room, about academic work on path verification protocols, because as mentioned by Nicola and other speakers, there is a lot of interest right now in path verification mechanism. In recent IETF meetings, we talked about network attestations, path verification, proof of transit, and as work is ongoing, it's interesting to go to academia and and look what academics have done on those topics and how they address the topic. So what we've done is that we started from a research question. We try to avoid reinventing the wheel as much as possible. So when we have a question, we try to go to academics and see what are the works that have been published on, for instance, proof of transit and path validation. And we looked at several papers that have been published. You see a stack here. And what we wanted to see is that what are the implications of some security properties that are provided by those mechanisms with regard to the costs that they put on the network and on the processing of packet in terms of header overhead, in terms of cryptographic overhead and computing power consumed that equipment. Because depending on what you want to address as a threat and what are the resources that you have on your routers, you may or not adopt several mechanisms. And in several occasions, when we talk about proof of transit, when, for instance, this morning during the NASR BOF, lots of people are concerned that if we do path validation, then it would be very costly and it would be infeasible. So we wanted to check whether this was really impractical or if it was practical. So what we did first was to look at the header overhead of proposed proof of transit mechanisms. So we looked at those papers that I listed earlier, and we built such fantastic tables comparing the various mechanisms that were published in academia with regards to some design properties and design aspects. So for instance, on the slide that you see on the screen, you have the scheme characteristics. The scheme characteristics describe whether when you have a path between a source and destination and with intermediate nodes, whether the intermediate nodes verify the path or not, whether the source and the destination trust one another, whether the source authenticates to the destination or not, and whether those schemes are deterministic or probabilistic. And according to those scheme characteristics, we derived what was the impact on the error size of the header that was formalized by those academic works. And so we looked at those tables. We added internet drafts that were published in IETF 119, and we tried to derive some general considerations from the results we obtained. Stuart, you are in the queue. Do you want to ask a question now?
Quick question of clarification. The column with the header mutual source destination trust, does that mean that the scheme requires some prior establishment of such trust, or that the scheme provides such trust?
It means that the scheme provides this trust, because usually those schemes come with the definition of a key distribution mechanism, and how you distribute the keys is related to how you establish trust in the mechanism. Okay, so in the column that you see on the right, you see the impact of the security provided by the mechanism compared to the minimum address size. The minimum address size is the overhead of the system that is taking the least space in the other overhead. So you have a scaling factor that you see, and we'll see how this factor is impacted. And in general, this is like opening a revolving door, but the more security features, the larger the header. Rocket science, but yeah, it's confirmed. In the header size that you see here, you see that some elements are factored with n being the number of intermediate nodes that you see on the path. In fact, the presence of this n is is translating the fact that on some schemes, the intermediate nodes on the path are providing intermediate verification. So when such intermediate nodes operate and perform intermediate verifications, they need to have information they retrieve from the header. So with those schemes, the larger the path, the larger the overhead. To mitigate these aspects and still provide a sense of verification by intermediate nodes, you have some schemes that are denoted as probabilistic. And in fact, on those mechanisms, intermediate nodes can verify some packets, and the fact that a given intermediate node needs to verify this packet or not is given by a probabilistic distribution. So we accounted for the probability that nodes on the path would verify, and we took it into account in the computation of our overhead here. So this addresses the first question that we raised at the beginning. What is the impact of some security properties that we want to provide with proof of transit mechanism on the header overhead? Now, the second question that we have, and we repeatedly have to answer, is what is the performance impact of applying proof of transit mechanism on the traffic that we convey using those proof of transit mechanism? So the methodology we adopted, I'm really fond of Excel spreadsheets. So we built a spreadsheet like this. This spreadsheet represents manual counting of the cryptographic operations that are performed in the description of the proof of transit algorithms that is given in the academic papers where they are described. So I read those papers, I listed each and every cryptographic operations that was done on those papers, and compared the time taken to perform those operations with the publicly available cryptographic benchmark, which is the performance figures of the Crypto++ library. I verified that the results that we obtained with this manual counting are consistent with the results that we obtained with the kernel implementation done by Luigi on the proof of transit mechanism that we have described and presented in last IETF in spring. The results were consistent. We were confident enough that I didn't count it bad, so we are daring presenting the results here. In fact, in proof of transit mechanism, most of the time you have a setup phase and a data transfer phase. In the setup phase, you set up the cryptographic material on the various intermediate nodes that is going to be used to perform the path verification operations during the data transfer phase. You see here a comparison of several mechanisms. So on the right-hand side, you have the name of the different mechanisms. And here you have a plotting of the time taken to set up the whole path according to the number of nodes on the path. So we took from two intermediate nodes to 12 intermediate nodes. We considered it was consistent with the type of path you have on the internet. We discovered that when you do diffillment key exchange or with several intermediate nodes, this takes ages because public key cryptography is not really performant in the internet, even if you are using elliptic curve cryptography. So you can alleviate the effect and the performance burden of using public key cryptography to establish shared keys between source and intermediate nodes by using two sort of method. The DRKey method that was designed by researchers at ETH Zurich, closely working with Cyan, or symmetric key predistribution by hand, by configuration, you name it. Now, also in the setup phase, signing the information of the session, signing the path is not representing a very large impact on performance. So just sign it. It's not a significant. It's not a significant penalty, and you have added security feature. Then we looked at the data transfer phase. Data transfer phase is when you have established the cryptographic material with all the intermediate nodes, and the source and destination can perform the path verification and the path validation operation according to the mechanism. There is one mechanism in the literature that keeps on using public key cryptography for its operation called ICING mechanism from 2014. So those time, and it's impractical to operate on at layer 3. So we decided to take it out of our dataset and compare the other options with that are using pre-established symmetric key for the path validation operations. So you have the OPT family of mechanisms, the EPIC family of mechanisms, mask, ripple, PPV, service 6 proof of transit, which is the mechanism that we have presented last IETF. And we looked at the impact of the protection level for mechanisms that propose different levels of protections. For instance, OPT, which is work closely related to Cyan, propose mechanism with different levels of path protection with regards to their cost in terms of header overhead and cryptographic computation overhead. And what we see here is that, of course, depending on the level of protection, you get more performance penalty. But depending on whether you are using OPT or EPIC as a basis for your proof of transit mechanism, the impact of adding protection is higher or lower. And OPT performs in a very good way with regards to improving protection on the path compared to EPIC. So, in fact, what as a summary and as a key message, as a key takeaway message from this presentation, I would like to stress that from our observation, obviously not in production environment, but on something that we actually developed and deployed in a Linux kernel and measured from an experimental perspective, we shouldn't be afraid of performing proof of transit in the internet, because the impact of such mechanisms can be controlled and is limited if we don't have a very high protection level. So we can steer whether we want to have a high level of protection with a high cryptographic cost, but if we want to limit the cost of proof of transit from a cryptographic perspective, there are some mechanisms that already provide some good protection and properties of verifying the path that can be used, that can be deployed, and that can be beneficial to the community. So thanks a lot. If you have questions, I'm open to answering as much as I can.
Okay, I do not see anyone running to the mic and no one in the MeetEcho queue. So I guess, but I hope people will continue discussion on the list.
Yeah, sure.
I see. Yes, thank you very much for presenting. Very interesting. Okay, this concludes the session. Thank you very much for attending. I know it's Thursday, everyone tired. And I hope to see you all in Dublin